For years, the James Webb Space Telescope has represented the pinnacle of space exploration. With its enormous golden mirror and unmatched ability to peer into the distant universe, it has revealed galaxies born only a short time after the Big Bang, uncovered the atmospheres of alien worlds, and captured images that changed our understanding of the cosmos. Many people assumed Webb was the ultimate space telescope, the final step in humanity's quest to observe the universe. But another mission is preparing to take astronomy in a completely different direction. Instead of focusing on tiny sections of the sky with extraordinary detail, NASA's next great observatory is designed to survey enormous regions of space at remarkable speed. Its purpose is not simply to produce beautiful images. It is built to answer some of the biggest questions in modern physics by revealing patterns spread across the entire universe. This telescope is the Nancy Grace Roman Space Telescope, and although it is often compared to James Webb, its mission is entirely different. Rather than replacing Webb, Roman is meant to explore areas that Webb was never designed to study. Scientists believe that everything we can directly observe, every star, planet, galaxy, cloud of gas, and even ourselves, accounts for only a tiny fraction of reality. Most of the universe remains invisible. Hidden forms of matter and energy dominate the cosmos, yet they cannot be seen with ordinary telescopes. Roman has been built specifically to investigate this mysterious side of the universe. At first glance, its specifications may not seem revolutionary. Roman's primary mirror measures 2.4 meters across, similar to the famous Hubble Space Telescope and much smaller than Webb's massive 6.5-meter mirror. If mirror size were the only measure of capability, Roman might appear less impressive. That assumption couldn't be further from the truth. The true strength of Roman lies in something far more powerful than mirror diameter. It possesses an incredibly wide field of view, allowing it to observe an area of sky roughly 100 times larger than what James Webb can capture in a single observation. Imagine trying to understand an entire forest. Webb examines one remarkable tree with incredible precision, revealing every branch, every leaf, and every tiny detail. Roman, however, flies high above the forest, mapping the landscape as a whole. It identifies where different forests grow, how they connect, and how the entire ecosystem changes over time. Both approaches are essential, but they answer completely different scientific questions. Some mysteries simply cannot be solved by studying individual objects. To uncover the true nature of the universe, astronomers must observe millions, even billions, of galaxies together, searching for enormous patterns hidden across cosmic distances. That requires an observatory capable of surveying vast regions of space with exceptional efficiency. This is exactly the role Roman was designed to perform. Rather than concentrating on one galaxy for days or weeks, Roman will rapidly scan huge portions of the sky, collecting an unprecedented amount of information. Every observation will add another piece to an enormous cosmic map, allowing scientists to examine the universe on scales never before possible. The mission represents a shift in the way astronomy is conducted. Instead of asking what a single galaxy looks like, researchers will begin asking how countless galaxies behave together across billions of years of cosmic history. That change may prove just as revolutionary as any image James Webb has ever captured. And once Roman begins its survey, humanity may finally gain the tools needed to investigate the invisible framework that shapes the universe itself. The reason Roman has generated so much excitement extends far beyond its impressive technology. Its true objective is to investigate the greatest mystery in all of cosmology. Everything humanity has ever seen, touched, or measured represents only a tiny portion of existence. The stars that illuminate the night sky, the planets orbiting distant suns, the galaxies stretching across space, and every atom that makes up life account for just a small fraction of the universe. The overwhelming majority remains invisible. Scientists divide this unseen realm into two enormous components: dark matter and dark energy. Together, they dominate the universe, yet no one has directly observed either one. Dark matter first revealed itself through gravity. When astronomers measured how galaxies rotate, they encountered a problem that should not have existed. The visible stars simply did not contain enough mass to keep those galaxies together. According to the laws of physics, many stars should have drifted away long ago. Instead, they remained locked in place. Something hidden was producing additional gravity, acting like an invisible framework that prevented galaxies from falling apart. Although no telescope has ever photographed dark matter itself, its gravitational influence appears throughout the cosmos. Dark energy presents an even deeper puzzle. Rather than pulling objects together, it seems to be driving the expansion of the universe faster and faster over time. Instead of slowing after the Big Bang, space itself is stretching at an accelerating rate. Whatever is responsible for this behavior appears to dominate the universe on the largest scales, yet its true nature remains one of science's greatest unanswered questions. Roman has been built specifically to investigate both of these cosmic mysteries. Instead of attempting to observe dark matter or dark energy directly, the telescope will study the effects they leave behind. By measuring how invisible forces influence galaxies and the light traveling through space, Roman will create one of the most detailed maps of the universe ever assembled. Its most powerful scientific tool is a phenomenon predicted by Albert Einstein more than a century ago. According to general relativity, massive objects do not simply exert gravity, they actually bend the fabric of space and time itself. As light travels through this curved landscape, its path changes. When enormous concentrations of matter lie between Earth and a distant galaxy, the galaxy's light becomes subtly distorted before reaching our telescopes. Sometimes the effect creates stretched images. In other cases, it produces faint arcs or slight changes in a galaxy's apparent shape that are almost impossible to notice individually. These tiny distortions are known as gravitational lensing. On their own, they reveal very little. But when measured across an enormous number of galaxies, they expose something extraordinary. Hidden patterns begin to emerge. Those patterns trace the invisible distribution of matter throughout the universe, allowing scientists to map structures that no telescope can actually see. This is where Roman will transform modern astronomy. Previous sky surveys examined millions of galaxies and provided valuable clues about the universe's hidden structure. Roman will expand that effort dramatically by observing roughly 2 billion galaxies across an immense region of space. That leap in scale changes everything. With such an enormous sample, the subtle fingerprints of dark matter become far easier to detect. Instead of isolated hints, astronomers will be able to construct vast three-dimensional maps showing how invisible matter is distributed across billions of light years. At the same time, Roman will monitor how the universe has expanded over nearly 10 billion years of cosmic history. By studying distant supernovae and the large-scale arrangement of galaxies, researchers hope to determine whether dark energy behaves exactly as current theories predict, or whether it points toward entirely new physics waiting to be discovered. The answers could reshape our understanding of the cosmos itself. For decades, scientists have known that something unseen governs the structure and evolution of the universe. Roman may finally provide the precision needed to reveal how these invisible forces truly shape everything around us.